Hey everyone, thank you for checking out A1 Math. For today, this is part 2 of similar right triangles. What we want to do here is solve for the missing line segments using our similar right triangle ratios. And if you remember from the last video, it was about the altitude rule and the leg rule. And today I'm going to do 6 problems. These are going to be a little bit more complicated and they're going to involve radicals. But the principles stay the same. You're going to use your altitude rule, which is part of the hypotenuse over the altitude over the other part of the hypotenuse, and the leg rule, which is the hypotenuse over the leg and the leg over the projection. So I'm going to show you how that works. So take a look at this one. We could tell, since we have the altitude, that what we want to use is the altitude rule. Okay. And with the altitude rule, what we're going to do is set up that ratio. And here's one way to always remember. If you're using the altitude, you're going to put altitude in the denominator of your first ratio and the numerator of your second ratio. So now I have 8 square root of 21, 8 square root of 21. And you could put either part of the hypotenuse either way you want to. So here's x, and here's 16. Now I'm going to stay the same and cross multiply here. And that's going to get us 16x is equal to 8 square root of 21 squared. Okay, now with this raised to the power of 2, what you want to do is you want to take the 8 and multiply it times itself to get it to be squared. So that's 8 times 8, which is 64. But to deal with the radical, you're going to multiply the square root of 21 times the square root of 21. And that's going to get you 21 without the radical sign or the square root sign. So now what you're left with is 64 times 21, and I'm going to bring down to 16x. When you do 64 times 21, that's going to get you the value of 1,344. And then our last step is to solve for x by dividing by 16 on both sides. Okay, and that gives us a value of 84. So our x over here is 84. So to recap, you want to set up your altitude in the denominator, then the numerator. Set the parts of the hypotenuse on each side, and then cross multiply. Okay, let's take a look at another example. Okay, now since we don't have the hypotenuse and we do have the leg, we're going to use the leg rule. And to find this x, we want to set up our ratios the same way. Now, this is the same thing as the altitude rule, but the leg is what we're going to use. And we're going to put the leg in the denominator and the numerator. And then we're going to have 39, which is our projection on this side, and x. Similar to the parts of the hypotenuse, it doesn't matter which part you put in. But the 39 is the projection, and we need the whole hypotenuse when we're dealing with the leg rule. So again, we're going to go ahead and cross multiply. And that's going to get us 8 square root of 39 squared is equal to 39x. Now if we do 8 times 8, that's going to get us 64. And the square root of 39 and the square root of 39 times itself would be 39. All right. Now, when we multiply 64 and 39, That's going to get us 2,496 equal to 39x. Then we're going to divide by 39. And that gets us x is equal to 64. And if you're really paying attention, you can see that 39 about to cancel itself out, leave you with 64 anyway. So the answer to the hypotenuse, this length here, is 64. So that's one example with using square roots for the altitude and one for the leg rule. Okay, I'm going to show you 4 more problems involving radicals or more complicated ways to use the similar right triangle. Okay, here are a couple more problems that we're working with as far as dealing with similar right triangles. Now, different from the previous problems we worked, you have the unknown value over here in either the leg or the altitude. Okay, so remember that we're going to multiply the leg or the altitude by itself. So this time we're going to end up with some squares, x squared. But it's no problem. It's basically the same, and I'll show you how to work it. So first we start off recognizing which rule this is. Here we have the altitude rule, the leg rule, because we don't have the altitude and we do have the leg. But remember, with the leg rule, you need the whole hypotenuse. So we're missing a value that we need to put in our ratio. Okay, kind of write this a little better. This is 27. So I need this whole value here, first thing, because I need to have the whole hypotenuse in order to make this work. So this value is going to be 36. Now I'm going to go ahead and start to set up my ratio. So I'll go ahead and set up a x here and an x here, because that's my leg. And then I'll go ahead and put my values in. I'm going to put a, let's say, 27, since that's the projection from this part of the leg, and the whole hypotenuse, which is 36. So the next thing I'm going to do is go ahead and cross multiply. And when I do that, that's going to give me x squared is equal to 972. And then the next thing you want to do is take the square root. That 972 is pretty big. So when you have a number like that and we have to simplify the radical, the first thing you want to do is type 972 into the calculator to see if you can get the square root. There's no perfect square for 972. And then you go through your perfect squares. Like 4, 9, 16, 25, 36. This was pretty big. It's actually the perfect square of 18, which is 324. So what you're going to do with the 324 is, when you divide it to 972, you have 324 times the square root of 3. And once you take the square root of 324, this is gone now. That's going to leave you with 18 times the square root of 3. So this will just be 18 square root of 3 for my answer. So that's the value that we have here for this leg. Okay, so that's one example showing two new points. One, that sometimes your leg or altitude could be your unknown value. And second, sometimes you have to look to see if you have all your pieces that you need in order to work your particular rule, whether altitude or leg rule. So let's take a look here at number 4. Now, in number 4, we have x, our unknown value here at the altitude. But to work the altitude rule, you need parts of the hypotenuse. We have one part, but we don't know the other part. So in order to get that part, what we'll need to do is take the 64 and subtract 9. And that's going to get us 55. So taking the 9 off of this shows that the value right here is 55. 9 and 55, 64. So now that we have the right pieces to the hypotenuse, we can go ahead and work the altitude rule. And the altitude being x will go in the denominator and the numerator, leaving our other two pieces to fill in the rest. All right, now we're going to cross multiply here, and that's going to get us x squared. It's equal to 9 times 55, 495. And we're going to take the square root. So when we do that, we have x is equal to square root of 495, which is not a perfect square. So you have to use one of our perfect squares to divide into it. But if you notice, we already know a perfect square is a factor of it because we just multiplied. So let's just use that one. And we know that 55 cannot be simplified. So we know that it's going to be the square root of 9 times the square root of 55 here. And then the square root of 9 is going to be 3. And we leave our 55 here. 3 square root of 55. All right. So that lets us know the value here for x, which is 3 times the square root of 55. And that's 2 more problems using similar right triangles. Now I'm going to show you a couple more where you have to do this add and subtract piece, but you have an unknown value and how to solve it from there. Okay, here's our last 2 examples for dealing with similar right triangles. As you can see, we have a mix of everything here in number 5. We've got our square root that's already one of our values. We have our unknown here. And since we're using the altitude rule, we need to find this piece here. So we've got a lot of stuff going on in this one. But let's take a look. First, I'm going to start off by setting up my ratio. And I know I have the altitude. And the altitude is going to be 9 square root of 3 in the denominator and 9 square root of 3 in the numerator. So what I need is my other 2 pieces for the altitude rule. So I have 1, which is 9. Okay, and I need this other piece. Now, to get that, whatever this x value is, I need to subtract 9 from it. Okay, so I gotta take this value right here is x minus 9. X minus 9. So now that I have that, I'm gonna go ahead and place that here. And I can go ahead and set it up and work the same rules we've been doing. I'm gonna cross multiply. here. And when I multiply this 9 times x minus 9, I have 9 times x minus 9. And over here, I have my 9 times the square root of 3 times 9 times the square root of 3. So I can take the 9 times 9, and that's going to give me 81. And the square root of 3 times the square root of 3 is going to be 3. And if you want to write that additional step where you have 9 square root of 3 squared, you could do that as well. All right, now I'm going to distribute the 9. 9 times x is going to be 9x. And 9 times negative 9 is negative 81. And 81 times 3 is going to be 243. Now from here, it's just regular algebra. You can go ahead and add 81 on both sides. Bring down my 9x. 243 plus 81 is 324. Next, I'm going to divide by 9. And that's going to leave me with a value of 36. So, it's a few more steps when you have to do the subtraction and you have the unknown and everything. So, but you just take your time, place the values where they need to go. Don't rush and put the wrong value in the wrong place, and you'll be fine. Okay, let's take a look at this last example. Now on this example, we're going to use the leg rule. Now in order to use the leg rule, you need the whole hypotenuse. Okay. So to get this value here, that's going to be 16 plus x. So I'm just going to go ahead and call that 16 plus x. And go ahead and set up my ratios here. I'm using the leg rule, so the leg goes in the denominator and numerator. And I can put my other pieces where they go. Same thing, I'm going to cross multiply. That's going to give me 20. 20 times 20, go ahead and write that, which is 400. It's equal to 16 times 16 plus x. Okay. When I distribute the 16, that's going to be 16 times 16, which is 256, plus 16x. Go ahead and subtract 256 on both sides. And leaves it 144 here. Bring down my 16x. And last but not least, go ahead and divide by 16. And x is equal to 9. So the value that goes in here is 9. And if you want to double check, you could take a look and see that they make sense. If we plug 9 in here then the value for the whole hypotenuse is 25. And if this is 25, it makes sense that it's longer than this leg, which is 20. So even our values make sense. If you happen to have, let's say you have, I don't know, 28, and you see that this is 28, but this is 16, you may have done something wrong. So you want to be close to make sure that your values make sense with what you're working with. So again, this is similar right triangles with the altitude rule and the leg rule. And I want to thank you for checking out A1 Math. Have a nice day.